Exit Glacier in Kenai Fjords National Park is one of more than 35 glaciers that flow from the massive Harding ice field. Though smaller than many, it is easily accessible by road and is one of the main tourist attractions in the park. Local visitors who come back year after year noticed what they saw as accelerated melting of Exit Glacier in recent years, and many took this as a clear sign of global climate change. The only way to really know, though, whether the retreat of the glacier is truly accelerating, is to know how fast it has been melting over the past couple of centuries. The answer to that question came coincidentally from another project that was looking at plant nutrients in the Exit Glacier area. Joel Cusick, now a National Park Service GIS specialist, did a master's thesis that was focused on whether leaf nutrients could be analyzed to tell the age of the landscape.
In order to get at this point, I had to look at I had to redefine the timing of the glacial retreat at Exit Glacier. The best way, and the way that I started out this quest, was to find as many historical photographs, ideally taken from an aircraft, flown over the terminus or the snout of Exit Glacier over time. Then, taking the age of the photograph, I can merely trace the contour of the glacier in relationship to other objects that I can see inland, and then I can say quite definitively that the glacier was there at time of photograph. So historical evidence from photography is the ideal way to do it.
Unfortunately for Cusick, photography of the Exit Glacier area, particularly the overhead aerials that are most useful, only goes back to the 1950s. But there are other methods of tracking the glacier's retreat, such as dendrochronology, or aging a landscape by counting tree rings.
If the glacier sits over time in one general location, you have kind of a conveyor belt situation where you have rocks from the middle of the glacier moving to the end, and they kind of get dropped off at the end of, or the snout of the glacier. And over time, if the glacier sits in a relatively stable environment, it'll build up a pile of rocks at the tip of it. Once the glacier moves off of that spot, you've got a physical piece of evidence of a glacier location at some point in time. Now fast forward as through many seasons of growth, that the vegetation slowly will take over that rock pile, and eventually a tree will sprout from the tip or the top of that moraine. That's the ideal, that's the location where I was trying to core the trees from, is on the top of the moraine or the distal part of the moraine that's away from the glacier.
Cusick and his team identified 10 moraines left behind by the glacier as it retreated up the valley, and cored some 207 trees on these moraines.
Hopefully you hit the exact center of that tree, or the pith. You do some techniques to highlight those tree rings to bring them out for the naked eye, and sometimes you use microscopes to help you count those rings. Ideally, that's the age of when the tree has sprouted or began its first year of growth on a rock pile. Well, that does not yet tell you that's when the glacier was there. So the time from glacial retreat to the first sprouting of a seed of a tree is another interval that you have to take into consideration, and that's called the echesis interval. Echesis is the time that it takes for the seed to arrive from some source and grow.
Cusick was able to correlate known positions of Exit Glacier from aerial photographs with tree ring counts from those positions and determine an echesis period of 5 years for cottonwood trees and 25 years for spruce.
So spruce and cottonwood were the two trees that I cored on these moraines on the glacial forelands of Exit Glacier to help me determine the age of moraine deposition when the glacier retreated.
Fritz Klasner is a Natural Resource Program Manager who's been monitoring Exit Glacier's position for the last several years.
Exit Glacier is one of many glaciers across the state, south central Alaska, across the state of Alaska, North America, and across the globe that are retreating. Joel's work gives us a real tangible and concrete example of how the ice has retreated in Exit Glacier Valley since the maximum in the Little Ice Age. As you're driving up the valley, there's the signs marking the dates when the ice was where, and it just really gives you the impression that you're moving through time.
Oh, it's definitely an estimation. I would probably have to say for Exit Glacier it's plus or minus 10 to 15 years.
So with the positions of Exit Glacier's terminus for the last 2 centuries now accurately mapped, what does it tell us? Is the rate of Exit Glacier's retreat actually accelerating in the face of global climate change?
From the perspective of the past 200 years, it's retreating at about the average rate. And I want the average rate being at about 13 meters per year. That said, from the local perspective of 10 years or even 30 or 50 years, you could easily understand why someone would say it's accelerated, because it has over that time frame. There was even a period in the early 1990s where it advanced, and so it's really it sort of depends on your frame of reference. You know, you had this 10-year period where it either stayed the same or advanced or only retreated very slightly, to now you're retreating 10, 15 meters a year. That's a significant acceleration in the rate of retreat. But it really depends on the sort of the time frame or the window that you look through to evaluate it.
The Exit Glacier has been retreating and thinning along its margins. Much of the rock that has been hidden from view, at least since 1815, is being exposed for the first time for at least 200 to 300 years, maybe more. I can't say anything past that. But some of that rock has been exposed on a yearly basis, and hundreds of meters have been exposed to the sunlight.
The information, what we're seeing in Exit Glacier, is representative across the globe, that as temperatures warm, ice doesn't do as well.
Exit Glacier is retreating more rapidly than it has in recent memory, but it does appear from Cusick's work that it has had similar periods of rapid retreat during the past 200 years. While no one glacier can tell us about global climate change, Exit Glacier's accelerated retreat is consistent with what's happening to the majority of the glaciers around the world. This evidence, taken as a whole, is one more indication that climate is warming and that glaciers like Exit may soon disappear.